Okay, next problem on solving quadratics. This is one of the most common problems you're going to see with the parabola, and that's the idea of throwing a ball. So a ball is thrown vertically upward from a roof that is 192 feet high with an initial velocity of 64 feet per second. That's where you see the 64 here, and you see the 192 there in the equation. Its approximate height after t seconds is given by, so h is for height, t is for time in seconds, negative 16t squared plus 64t plus 192. Completely factor. Okay, so if we want to factor this, we need to find, is there a GCF? That's the number one rule of factoring. And also, if it starts with a negative, let's factor out a negative. Is it 16? Does 16 divide over? Okay, let's factor out negative 16. T squared. How many times is 16? Oh, that's negative 4t, right? And how many times is negative 16? Negative 12. That was great because this allows us to continue factoring. T, give me the two numbers that multiply to negative 12. Negative 6 and positive 2. Right. Use your calculator to graph. So again, you kind of can see from this graph what your x maximum, your x minimum, your y maximum, and your y minimum will need to be. So if I go to my graphing calculator, turn it on, go to y equals, clear out anything I have, and I'll just type in negative 16. Now it's also very important that you use the negative symbol here at the very bottom when you do negative 16 instead of minus, because otherwise you'll get a syntax error. You learned that the hard way, didn't you? Now also, if you want, you can type in, you're going to use x and not t, x squared plus, 64x plus 192. Your calculator will not know what to do with a t, so don't do an alpha lock and get all fancy and try to put a t in there. If you weren't sure if your factors were correct, you could put in the exact same factored equation and you would get the same graph as well. Okay, I want a better looking graph than that. So I'm going to use my window button and I'm going to use the graph that I already have here to set my minimum, maximum. The minimum, okay, negative 4, that's fine. X maximum, it's only going out here to like 8. You know, you can round a little bit. You could put 10 if you want, but I'm going to put 8. Okay, scale is counting by 1. My Y minimum, I don't need to go very far because remember that the ground is where y equals 0, right? Because that's height above the ground. So that's the ground. So let me just put negative 2 for y minimum. Y maximum, I'll round it off to 300. And then the scale here is counting by, it actually looks like it's counting by 10. So now let's go graph. And remember, this scale doesn't really matter. It's just where are you seeing the tick marks, okay? So now you can see all of this. Oh, I forgot to show you on the last problem the intersect feature, but maybe we'll be able to do that here. Okay, sketch the graph from the calculator. I don't want to just draw this out, so I'm going to go second table, and I'm going to put in the values from my table. So Y-intercept. Who can tell me without, before I get to x equals 0, does anybody have any ideas about the y-intercept? What's the y-intercept going to be? 192, because that's where it starts. So 0, 192 is approximately here-ish, right? That's 190. And then 1 to 40. So after 1 second, it's 240 feet above the ground. After 3 seconds, because I'm just getting this from the table, or sorry, 2 seconds, it's 256. 256, so around here. Okay, after 3 seconds, it's 240. 3 seconds, 240 is here. Oh, and there's that symmetry happening again. You see how The vertex, what point does the vertex have to be? Yeah, it has to be 256. Okay, that's that point there. Because there's symmetry. So after 4 seconds, it comes down to 192. And then you can actually even see from the table of values here, where does it land? 6 seconds, because that's 6 comma 0. That's an x-intercept. That's when it's on the ground. So this is the trajectory over time. Okay, is this parabola shape. That parabola opening downward is because of that negative 16 coefficient. Algebraically determine the solutions. Okay, plot and label the points on the graph. Interpret the meaning in the context of the horizontal intercepts, in the context of the application. So if we're going to set it equal to 0, aren't we going to factor? We already did that, you guys. We already factored it. Remember? T plus 2, t minus 6. So what are the two numbers, the t values, that will give you your zeros? Negative 2 and what else? Positive 6. So the ball, let's make a, so we have negative 6 and, positive 6 and negative 2. Why am I'm drawing this other end dot, dot, dot? Because think about real life for a minute. Can the ball fall on the ground negative 2 seconds after it was thrown? Because you don't have a time machine. You're not going back in time. You're not Michael J. Fox. You don't have a DeLorean. So you can't. Right. Okay, I get it. You had to climb the stairs. But but the thing is we want to know, when did it hit the ground? The ball hit the ground when? 6 seconds. Oops, ground. 6 seconds after it was thrown. And remember, you can always take these numbers and plug them into your equation to check. Plot and label the vertical intercept on the graph. The vertical intercept, what does the vertical intercept also mean? Yes, vertical intercept is the y-intercept. Y-intercept. What is the y-intercept? The y-intercept is 0, 192. 0, 192. Who can interpret what does it mean in the context? The ball starts at 192 what? Seconds or feet? Feet. Are they talking about feet? Yes. Feet above the ground. And I plotted and labeled it here. There's my intercept over here. Negative 2, 0 is another intercept. Plotting and labeling. And the reason why I'm kind of going through and modeling this for you too is on a test, all of these directions count for points. So a lot of times people will not do all of the things, so make sure you do all of the things that are being asked. Okay. E, use the height equation to determine the height of the ball after 5 seconds. Plot and label this point on the graph. Interpret your results in a complete sentence. So if we go t equals 5 and we say h equals negative 16 times 5 squared plus 64 times 5 plus 192, well, I already have that number on my table. So I'm going to assume my calculator did it all correctly. I got 112. And what does that mean? So our ordered pair is 5, 1, 12. Yeah, and I didn't plot it before, but here it is. 5, 1, 12. And you're right. After 5 seconds, the ball is 112 feet above the ground. Okay, algebraically determine how long will it take for the ball to return to the height of the thrower, 192 feet. So algebraically means I need to see all of your work. So the height is 192 equals the equation t squared plus 64t plus 192. So they want me to solve this. I plugged in height equals 192. What do I need to do to solve this algebraically now? Bingo! Because we have to set it equal to 0. I'm going to subtract 192. How convenient that that cancels out. 0 equals negative 16t squared plus 64t. How do I solve that? Yes, greatest common factor. What is the greatest common factor? Yes, it is. T minus 4, right? So you have t equals 0 for this one. T equals 4, which we also saw. So it takes 4 seconds for the ball to be 192 feet above the ground. So if we look back at our table, our graph over here, here's plot and label. Plot for 192. So what you're going to notice is I'm going to see a lot of things going on in your graph, right? You're going to plot the points. You're going to label the points. Remember that if it says interpret your results in a complete sentence and you don't have a complete sentence, you lose points. I had a student in Math 95 one time, they got a 97% on their test. You know why? They were supposed to write 3 complete sentences and they didn't write their 3 complete sentences. So they learned the hard way. Okay, algebraically determine how long will it take for the ball to reach a height of 240. So we're going to literally do the exact same thing here. We're plugging in 240 for the seconds or the height? The height. Negative 16t squared plus 64t plus 192. What's the very first thing I did was I plugged in the height of 240. Now what should I do? Okay, because you want to set it equal to 0. So 0 equals negative 16t squared plus 64t. What's that? Is that right? 48? You all checked his math? Okay. Okay, now what do you want to do? It's so nice, these factoring ones, they come out so neat. They don't always do this in real life, right? Could we divide everything by negative 16? Why am I dividing it out instead of factoring it out? I can. How come I can? Because I'm solving an equation. Whenever I solve an equation, I can do whatever I want so long as I do the same thing to both sides. Do you have the answers? Is that why you're excited? Oh. Oh, that's a positive, sorry. So it would be minus 3 minus 1. What would t equal? And 3. 1 and 3. So at 1 second and 3 seconds, the ball is where? It's at 240 feet above the ground. Now it also says to plot and label these points. So we go back to the graph. Here we have 1, 240, and you guys, these were on our table, 3, 240. You can go back to the table. Table is helping you with your check, right? There it is, 1, 240, 3, 240. Now, could you have just, would it have been acceptable just to like go to the table and get the answer and just write the answer down? And I will say the answer to that is no, because it says algebraically determine. All this part, algebraically, this is the algebraic solution, right? So that's important too. Okay, now it says use the maximum feature on your calculator to determine the maximum height of the ball and the time to reach that height. Plot and label that point. Now, because there's symmetry, it has to be 2. Does everybody understand why 2 seconds has to be the time? It's the middle of 1 and 3. So there is that symmetry happening. Okay, if I go back to the graph, I forgot to show you guys the intersect, but it's the same, it's in the same menu. If I go second calculate, oh my gosh, I get this whole entire value. I get this whole entire calculate menu. Value, 0, minimum, maximum, intersect. The intersect could have been used to find the intersection between those two lines. I meant to do that on the last problem. Maximum, is that going to give us the vertex? Yes. Enter. So left bound means I just need to go anywhere to the left of the maximum. Enter. Right bound, I'm going to scroll to the right, enter, and then guess, push enter again, and there's that maximum. Now it's actually not, it needs to round it. There's a little glitch with the calculator. It's really not 1.9 repeating, it's really 2. 256 is the vertex, okay? Or the maximum, because the parabola is opening downward, here it is, and I plotted and labeled it already. How would you interpret it in a complete sentence? After 2 seconds, the ball will reach a maximum height of 256 feet, period. I like it. Okay, any questions on this? There's a lot of questions here, basically all pertaining to the same problem. So you can see all of those different variations on types of problems, finding. We got it because we used the calculator to find the maximum here.